Transportation problem. So transportation problem actually helps to solve the special type of problem of linear programming. In this, generally the transportation problem, when there are several factories and there are several markets, it helps us to allocate the factories to markets or supplier to demand. So and the goods are transported to factory to markets without violating supply restriction and demand restriction at minimum cost. So it's the thing, but shipment of goods from origins to destinations. Shipment of goods from origins or sources to destinations, warehouses with minimum cost. Transportation problem can be written as a linear program problem. Here, the linear programming objective function is minimize z equal to sigma I equal to 1 to n, j equal to 1 to n, cij xij, subject to sigma I equal to 1 to m, it is m origins and n destinations. So m to 1 to m xij equal to, so origins equal to sy. So origin is suppliers si for all I equal to 1 to m. Similarly for destination I equal to 1 to n, xij equal to dj for all j equal to 1 to n. Sigma I equal to 1 to m, s I equal to sigma I equal to 1 to n dj. So total supply is equal to total demand, another constraint, subject to xij greater than or equal to 0, non-negative constraint. Here I is the index for origin, j is index for destination, xij equal to quantity shipped from origin to destination, cij is the unit cost of shipping. SI, total capacity of origin I. DJ, total capacity of destination J. So this transportation problem is solved with different steps. First step is in a flow chart. I'll show you how to what are the first is formulation of transportation matrix. Next is check the whether transportation problem is matrix is balanced. By here we will check with the sum of the supply is equal to sum of the demand. If sum of the supply is equal to the demand, then go for initial basic feasible solution. If not, add dummy correspondingly. Suppose if the supply is less, add supply dummy. If demand is less, add demand dummy with zero transportation cost. Then find the initial feasible solution. By three different methods. Any of the method we can use. One is northwest corner rule, another one is least cost method, another one is Vogel's approximation. After finding initial feasible solution, next check is test for optimality. So if the solution is optimal, then that is called optimal allocations. Find total cost. This is called transportation cost. If it is not optimal, then revise the solution. This is a major steps in transportation problem. So first step, balancing transportation problem. Step 1, balancing transportation problem. So for example, one simple problem where there are three suppliers and four warehouses where demand is there, demand destinations. So transportation cost for this is 13, 16, 19, 17, 17, 19, 16, 15, 15, 17, 17, 16, and the supply quantity is supply is 250 is from supplier, 200, 250, and here it is 100, 150, 250, 100. If you sum up this, the value you will get is 700. If you supply, the demand is only 600. So this is unbalanced. So first balance. So balance means add one dummy of demand. Adding one dummy demand. Supplier 1, 2, 3, D1, D2, D3, D4, D5. 0, 0, 0 cost. Add the demand of 100. Here everything will be same. 150, 250, 100, 250, 200, 250. These are the number of units supply and demand. So now the transportation problem is balanced, 700, 700. So this is a transportation problem. Here remaining in the middle, the costs of transportation from one supplier to one demand destination are same. So once after completion of this, then we have to go to initial finding initial basic feasible solution. So initial solution, next step is initial basic feasible solution. So initial basic feasible solution is solved, done by three methods. One is least northwest corner rule. Northwest corner rule. So here in the above problem, S1, S2, S3, D1, D2, D3, D4, D5, 250, 200, 250, 100, 150, 250, 100, 100. So the costs we will show in brackets: 13, 16, 19, 17, 0, 0, 0, 15, 16, 17, 17, 15, 17, 19, 16. So after writing all the values, start with northwest corner rule. So first you have to take the northwest corner S1 D1 cell, allocate to that cell as maximum demand. What is the demand? How much? 100. So take 100 from the 250 of supplier 1, because you need to take allocate in the northwest cell. So first I am allocating 100. So once after allocating 100, cancel this cell. Okay. Then we have allocated 100 here on. Then go to 100 is allocated here. So this you have to delete this row, because 100 is 100 minus 100 is 0. So then remove the 100 minus 250, you will get 150. Then northwest corner is S1 D2. Then allocate to that cell 150. After allocating, cancel both cells. Okay, because here also 150, you will get equal to 0. 100 minus 100 equal to 0. So these are all got cancelled. Next is allocate S2 D3 with minimum of supply is 200 is there. Whichever is minimum, we have to allocate that. So allocate with 200 for S3 and cancel the 200 and remove 200 is equal to 0. Remove here 200, you will remain with 50. You have 50 demand here for the demand 3. So select next possible allocation is we have to allocate to S3 D3. Here it is 50. Now it is completely demand has met. Allocate here 100, here 100. Now look at the allocations. The initial allocations are 6 number of allocations. Number of allocations equal to 6, but optimal allocations is equal to the m plus n minus 1. Optimal allocations equal to m plus n minus 1, where m is the number of rows, n is the number of columns. Here rows is 3, columns is 5, minus 1, it is equal to 7. So our allocations are less than 6 is less than 7. So allocate some negligible value amount to random cell. So that's why I am allocating one epsilon value to cell D3, S1 D5. Allocating epsilon value. Next, now allocations will be equal to the 7. So then this is a initial basic figure based on northwest corner rule. Second method is least cost method. So after allocations, total cost of allocations is equal to 100 into 13 plus 150 into 16 plus 200 into 16 plus 50 into 17 plus 100 into 16. That is the total cost for allocations. Next, the total cost is 9350. Now this is about northwest corner rule. Next is least cost method. Second method is least cost method. In the same above problem, S1 is a source, S2 is S3 is a source, D1, D2, D3, D4 or D5 demands. Allocate the costs correspondingly 0 0 0 16 17 17 15 17 13 16 19 17 15 16 19. So demand is 100 150 250 100 100 250 200 250. So out of the cells, all cells, first select the least cost cell. Least cost we have 0, so allocate 0 here. Allocate 0. So I have allocated 0. Then after allocation, cancel that D50. So now you are remaining with supplier 3 only 150 units. You are left with 150 units with supplier 3. Next, look at the least cost. Next least cost other than D5. You have cancelled the D5 column. Next least cost is 15. There are two 15s. Select any 15, and I have selected this, allocated 100. So cancel that D4 column and select another least cost. So here allocated 100, so 200 minus 100, you are left with 100 with supplier 2. Next least cost is another 50. Sorry, before the 215 there is another 313, so allocate that 13 and cancel that column. We have allocated there 13, for that 13, so 250 minus 100 is 150. So after 13 you can allocate the 15. So then look at the least cost. Least cost is 16 out of all those things. So there are two 16s. One 16 is here, 100 I have allocated here, and another 150 is remaining. 150 allocated here. So there are another 150 remaining here. 150 50 you can allocate. So now we just check what D1 demand, 100 allocated, 150 allocated. It is here, it actually 150, not 1 second, not 50, it is 150. It is 150. So 250 allocated, 100 100, so everything all got allocated. So number of allocations is now number of allocations equal to 1 2 3 4 5 6 6. So number of allocations are less than the m plus n minus 1. Optimum allocations are has to be m plus n minus 1. So allocations are less than optimal allocations, which is 7. So again add some random value and then calculate the transportation cost. That's about least cost method. Next is Vogel's approximation method. In Vogel's approximation method, the penalty cost has to be calculated for each column and row. So same diagram. 16, 17, 250, demand required 15, 16, 100, 100, 0, 0, 200, 250. This is our initial setup.